So you'll hear about my company today, Modern Hydrogen. We basically produce clean hydrogen by stripping the offending carbon atom out of natural gas, and then we sequester that carbon as a useful economic product in roads. Probably the best way to learn about what we do, as of last month, there's a video now on the internet. Go Google Bill Gates pothole, and you'll find this video with 10 million views that explains what we do as a company. But I don't want to do this whole thing as like a company explanation. I want to set up the explanation of why we need hydrogen in the first place. So to be very clear, hydrogen is not the first solution you should look at for decarbonization. I'd actually say that now that human civilization has these tools called cheap solar and cheap wind, whenever you can use that first, when that's economical, we should use that first, because direct electrification with clean renewables is probably the best way to go to start reducing CO2 impact. That being said, those things produce electricity, and unfortunately, the climate change problem is not just about electricity. In fact, it's not just about energy. Pretty much every human activity today, whether it's agriculture or making things, ends up emitting CO2. And to just give the most visceral example I can give on how bad the situation is, and why decarbonization is hard, I want to give the example of how we make fertilizer for human beings. So today, there's this, the protein in your body requires nitrogen to make them. And so that protein comes from the food you eat. And within that is a synthetic fertilizer known as ammonia, NH3. So you'll see that the majority components of that thing is hydrogen. Today, that hydrogen is made from CO2-intensive processes from fossil fuels, and that is responsible for essentially half of the food, half the nitrogen in your bodies today, which means that if we stop using fossil fuels and stop using hydrogen derived from CO2-emitting fossils today, half of humanity will have to die, simply put. So this is why the energy transition is hard. And by the way, you probably noticed that you can't just eat an electron, at least I cannot. So this is not something that can be directly done with solar and wind electricity. And so this is one of the reasons why hydrogen now has a lot of support in trying to figure out how can we produce hydrogen cleanly and make this available for the energy transition. And in fact, some folks would call hydrogen the Swiss Army knife of decarbonization. Basically, hydrogen is a fuel and not an electron. So when you're dealing with a situation where you can't directly electrify and you want to use a fuel, well, hydrogen is that fuel. When you burn it, it doesn't emit any CO2. And that's why it would be the holy grail for decarbonization. And there's discussions to use this as transportation fuel for producing clean power when there's no sun shining or the wind's not blowing. You can use hydrogen to produce high-grade heat for industry. And as I mentioned before, you can actually use hydrogen as a material itself to make chemicals, to make fertilizer, to actually use it to make plastic, steel, food, glass. So this is why there's a lot of hype around hydrogen right now. I'm a scientist by training, so I cannot automatically suspicious of hype. So let me tell you about one of the drawbacks of hydrogen. It is one of the hardest fuels to transport and distribute. So it's a hard fuel to move from production sites to where the customer is. And it goes down to the fundamental physics and chemistry properties of hydrogen, but to give one example, if you have to ship hydrogen compressed in a tank, let's say you have two barrels. One has compressed hydrogen, one has just normal gasoline. Well, that compressed barrel of hydrogen only has 10% the energy of that tank of gasoline. So that makes it very hard to transport around. It doesn't have very high volumetric energy density. There are many problems like that facing hydrogen, but simply put, it all translates into economics, right? These are all solvable problems, but at the end of the day, this is an International Energy Agency report on everything hydrogen, and it just points out, forget about trying to produce clean hydrogen cheaply. If you have to move it any significant distance, the transportation cost overwhelms the production cost. So basically, our company takes a very crafty approach to looking at this. This only works in places where natural gas is important and cheap. But basically, we take a look, right? Natural gas is a fossil fuel. It is responsible for a lot of our CO2 emissions. But it is one of the biggest energy sources on the planet. In the United States, basically, if you ignore transportation, then natural gas is half of all energy. So natural gas is as big as coal, plus nuclear, plus solar, plus wind, plus hydro in the United States. And more importantly, we have a ton of infrastructure around it. There's already 3 million miles of pipes to transport hydrogen in the ground. It costs like $1 trillion and a century to build, but it's already there in the ground. I'll contrast that with hydrogen pipes. There's less than 2,000 miles of hydrogen pipelines in the country right now. 2,000 to 3 million. And when we nerds look at natural gas, we notice it's CH4 chemically, so it's 80% hydrogen atoms already. Most of it is actually technically clean. You just really don't want to burn that carbon atom. So our trick is basically producing clean hydrogen by stripping carbon out of natural gas at the customer sites. So don't change any infrastructure. The natural gas is being delivered where it is, going to all the factories today, and then just take the carbon out at the very last step. Then you do not need to wait a century and another $1 trillion to build up new hydrogen infrastructure. And most notably, our process of doing that also does not require any renewable electricity, which I think is very important because frankly, we need renewable electricity sorely to decarbonize all these other sectors that it feels really kind of bad to take away some electricity to produce clean hydrogen. So instead, we're just trying to remove all the carbon emissions associated with natural gas. Today, most of our applications are with utilities. I want to be very clear, like we only have a few pilots out into the field today. We're still a startup. But basically, the utilities have a lot of natural gas infrastructure, but now they should have a gun to their heads to try to reduce emissions quickly. They know that it's going to take them decades to get permit reform to build a lot of new infrastructure. So this is one of the quickest ways they can implement to start reducing CO2 emissions from their gas infrastructure right now. There's another trick here, which is when you splits away CH4, natural gas, into its component molecules, you actually produce a lot of carbon. Carbon is the heavier atom in this equation, and we produce about 4 kilograms of carbon per kilogram of hydrogen that is produced. So at scale, this would produce a lot of carbon. What do you do about it? This is actually an incredible opportunity. So to describe this, I need to describe briefly how our world is built in terms of roads. So most of the roads are built with materials that are dirt cheap. It's like stones, gravel, sand, and that's good. But to make it stick all together, right, there's that black tarry stuff. That stuff is called asphalt binder. It's actually made with oil, a very heavy form of oil called bitumen. So although that material, asphalt binder, bitumen, that's only 5% the mass of your roads, that's actually 90% of the cost of your road and 80% of the embodied CO2 emissions in the roads that are built around the world today. And this is a massive market, $100 billion per year. Turns out the way we extract our carbon with our chemical reactor reaction, the carbon we produce makes it a stronger and cleaner asphalt binder. So basically, not only are we cleaning up, making clean hydrogen to clean up, let's say, industry, transportation, all that, but actually the carbon we produce is also clean and can be used to decarbonize roads as well. So that's really our trick. Split a fossil fuel into two components that is actually, there's no CO2 emissions required, and then you solve problems on both sides. Now to end all of this, I want to talk about the project I'm actually most excited about. And here I want to give a big shout out to the Washington State Department of Commerce, which is sponsoring this conference, but is also sponsoring this project. And this is a cow poop project. This is what I love the most. Turns out, when you ferment cow poop, you can create a material called biogas. Basically, the cow ate some grass, right? The grass absorbs CO2 from the atmosphere, uses it to produce sugars. The cow eats the grass, and the cow produces cow poop, and that can produce essentially methane, biogas. But because essentially all that came from the atmosphere, biogas itself is already carbon neutral. Does that make sense? Because this is all biology. It's sucking CO2 out of the atmosphere to make the fuel. So if you burn biogas, it would produce CO2 back in the atmosphere, but it's a closed loop. There's no net CO2 created. That's already pretty wonderful. Now, when you take our process and you actually interrupt it by breaking the biogas into hydrogen and carbon, now we put the carbon into roads, right? It's permanently sequestered underground. So this is actually negative emissions. This is equivalent to pulling CO2 out of the atmosphere and putting the carbon back in the ground, which if you see the emissions numbers that has been going up, pretty much I'm convinced that we will need some way to repair the atmosphere to actually keep to our 1.2 Celsius or 2 Celsius goals. And I think this would be a pretty cool and scalable way to do it. So this project will be in Snohomish County, right here in Washington State. And yeah, again, like this ability to repair the atmosphere is one of the things that makes me more excited about our technology.